Hi everyone, welcome to the session on let me take a simple example. So I'll take a simple three bus system. This is second bus and this is. So we'll assume that there is an impedance connection between this and the ground and two. So I'll take this as bus number one, bus number two, and bus number three. Okay. Assume that the data given here are in impedance values J 0.5, J6, this is J 0.1, this is J 0.1. Here I have taken a simple three bus system and where the reactants are mentioned in terms of impedances and not in admittances. Now we are supposed to form a Y bus for this power system. And please make a note of this. I have not included the half line charging admittance. So this example and the following program will not have the code for including the half line charging admittance. So here we have taken an example excluding that. Now let us see what is the logic behind the Y bus formation. So we all know that this is a three bus system. So if you have a three bus system, then that means your Y bus will be of the order 3 cross 3. So totally you will be having 9 elements in the matrix. So I can represent like this. It is. So this is Y11, Y12, and Y13, Y21, Y22, Y23, Y31, Y32, and Y33. So now with this given data, we are supposed to write a code that will give us all these values starting from y11 till y33. It has to give us this matrix containing all the 9 elements. Okay. Now, what is the logic behind this? If you look at this, for there are two sets. One is diagonal elements, that is y11, y22, and y33. So these are said to be the diagonal elements y11, y22, and y33. So this is diagonal elements, or I can say self-admittance, and remaining y12, y21, etc. All those things are called as off diagonal elements, or I can say I can call them as mutual admittance. Now, only two methods are there. One method is to find out this diagonal elements, and another method is to find out this off diagonal elements. Okay. Now, to find out this diagonal elements, what is the method we use? We use the method called y. Suppose if I want y11, that means I will be summing up all the admittances connected to the bus number one. So sum of all admittances connected to bus 1. This is the logic, correct? Connected to bus 1. So according to this, if you refer the problem, then it should be 1 divided by j zero point 0.5 plus 1 divided by j zero point 0.6 plus 1 divided by j zero point 0.1. So between bus number 1 and the ground. So this is the logic we are following it for all the diagonal elements. For off diagonal elements, since it is a mutual admittance, so we are direct say for example, if I want to find y12, that will be same for y21, which is nothing but it is negative of the admittance between your bus number 1 and 2, that is J 0.6. Here 0.6 is the impedance between 1 and 2. 1 by J 0.6 is the admittance. So just you have to put a negative, and then negative admittance will be the off diagonal elements. So that's just two logic, right? So what is now just imagine what should be the outline of our MATLAB code. First we should get all the impedances. First we should get the number of buses and all the impedances connecting between the two buses. And once you get the impedance, you have to convert those impedance into admittances. And with when you're ready with the admittances, just check whether it is diagonal element or not. If it is diagonal element, do this. If it is off diagonal element, do that. That's it. So I'll just represent these lines again. So first thing is you have to uh, find read means you have to read the number of buses, okay, and get or read means you have to get the input from the user. Read the impedances between the buses, okay. Next, you have to once you read that, since you're getting impedance, convert impedance to admittance. Convert Z to Y. Okay, once you're ready with this data, you check whether for diagonal elements. Okay, for diagonal element, use that logic. So for half diagonal elements, you have to take the negative. That's it. That's it. Just you have to change these 5 sentences into a MATLAB code that is ready for now. Your YBus code will be ready. Okay, now so we'll go one by one. So first thing is we have to get the number of buses and the impedance between the buses. So that code is given at this point. Okay. So now this is the corresponding code. So before we go to this, I'll take this example. I'll bring this example at the bottom. So sorry. So now we will take this just a minute. Just a minute. Sorry. Sorry for that glitch. So now once you are ready with this, now we have to get the data. So how will you get the data from the user? So first you have to get these data. So now there are three buses: bus number bus number one, bus number two, and bus number three. So what I'm going to do is I'll fix first bus. So let me fix bus. I'll first fix bus number one. So when I fix bus number one, I want to find out what are all the impedances between bus one and one. That means here what I'm meaning is there you are checking whether is there any impedance between bus number one and ground. Next, you have to find out what is the impedance between bus number 2 and what is the impedance between bus 1 and 3. Okay, this is the first one. So by this you will get three values, no? So between 1 and 1 means it is 0.1. Between 1 and 2 it is J 0.6. Between 1 and 3 it is J 0.5. First one is over. So next, what I'm going to do is I'm going to fix a second bus, that is bus number 2. So when I fix bus number 2, as usual, what is the impedance between bus number 2 and 1? Impedance between bus number 2 and 2? What is the impedance between bus number 2 and 3? Here bus 2 and 2 means I mean what is the impedance between bus 2 and ground? So bus 2 and 1 it is J 0.6, bus 2 it is J 0.1, bus 2 and 3 it is J 0.3. And then next I am going to take the and third bus and third bus. Here third bus and third means I mean what is the impedance between third bus and ground? So if you see bus impedance between 3 and 1 is J 0.5, impedance between 3 and 2 is J 0.3, and impedance between 3 and 3 I'm just going to leave it as 0 because there is no impedances connected between the bus number 3 and the ground. So now if you see this, by this way you can collect all the datas, correct? So this is one method to collect all the datas of the buses. So this is the lot. So what then you are finding out the impedance from that bus to the remaining bus. So when you are when you are indicating in terms of loop, okay, so you require two variables here. So one variable is for this area, that is, let me take this as I, and so how the loop should be, the loop should be like this. So for if you're going to get the data for I is equal to, that is this loop, for I is equal to 1 to number of buses 3. And when you go inside, it is for j is equal to 1 to 3. So what happens? Equal to 1, and it will go from j is equal to 1 to 3. So we will be getting this logic. Next next I becomes 2. Again, when it enters here, it will take from 2 1 2 3. We'll get this logic. Then when I becomes 3, it enters here. It again takes j value as 1 2 3. So we will be getting this logic. So this is the logic behind using two for loops, that is one loop inside the other loop. So obviously, since we are having an element matrix, and since we want the matrix elements, you know that a matrix and each element is called or referred by a row and its column. So we require two loops compulsorily, one for the row and another for the column. That's why we'll be having two loops here for I and inside another loop that is for j. So with this note, we will directly go to the logic here. This is the logic behind the, as I already told you, first we have to get the number of buses. N is equal to input of enter the number of buses. Next, first step is over. Next, you have to read the impedances between the buses. So for that, I am going to start with the loop. So first for I is equal to 1 to n, go inside. For j is equal to 1 to n. Here n is number of buses. Here it is 3. Now, you all know that here we had a check, no? That is a check. If it is 1, 1, if it is 1, 1 means that means we are the impedance between ground and corresponding bus. If it is 2, 2, then that is the impedance between 2 and ground. If it is 3, 3, then that is the impedance between 3 and ground. That is why we have a check here. See, look at here. We have a check. So if I is equal to 3, if either 1 is equal to 1 or 2 is equal to 2 or 3 equal to 3 means, then it will print enter the impedance value between that bus and the ground. Otherwise, it will ask enter the impedance value between percentage %d and percentage %d. So this percentage %d corresponds to this first variable, second percentage %d corresponds to second variable. So by this way, you can get all the impedances from all the impedances data. And look at this, as soon as, so you are getting your impedance data in this variable called Z of ij. And what you are doing is you are doing the reciprocal because we want admittance, no? So I want y is equal to 1 by z. So I am writing y of ij equal to 1 divided by z of ij. Okay. Now here I am having one more check like this. One more check like this. Why? Because usually, suppose in this setup, in our bus, no, in our bus, actually, there is no impedance between 3 and ground. So what you will be giving, you will be entering the value as 0. Suppose if 0 comes here, 1 by 0 becomes infinity. So that is not a correct logic, right? So because if there is no impedance, that means you have to input it as infinity, and here it should become 1 by infinity as 0. So in order to avoid this confusion, we know that we are giving 0. Why? Because there is no impedance present between that bus and the ground. So that is why I'm having a check here to check if Z of ij is 0. I am assuming directly admittance is 0. Though this is not logically correct. Okay, I mean, from the electrical point of view, it is not logically correct. But for doing this problem, this is okay, permitted. So in the first loop, we have got all the impedances. Now we have got everything in this matrix called yi of j. So now we have all the admittances present in the matrix called yi of j. Now we will go to the y bus formation. Only two things. As usual, the loop is not going to change. You require two loops. One is for external loop. Another is for your internal loop. I is equal to 1 to n and j is equal to 1 to n. Now just look at this. This one is for diagonal elements. Diagonal elements means y11, y22, y33. That is why I'm checking, I'm making a check here. I'm going to check whether it is equal to 1 or not. So when 1 is equal to 1, 2 is equal to 2, 3 is equal to 3. Only for these three cases, this has to work. Otherwise, what is the logic? Otherwise, this is for off diagonal elements. You know what is the logic for off diagonal elements? It is just negative of the impedance. Just see here, it is nothing but a negative of your impedance. Simple. And here what we are doing is we are adding all the admittances. Sorry, it is negative admittance. We are adding all the admittances connected to that particular bus. That is why we are having a loop here. So this loop is for some. That's it. So I can let me show you the complete code for this. See, uh, as I told you, here you are getting the number of buses, and okay. And at this point, as you can see, this is the calculation part where this is for your diagonal elements and this is for your off diagonal elements. And finally, the y bus is printed. Now this is the sample output. Now look at this. I'm entering number of buses as 4 in this example. Without fail, please enter in terms of your imaginary part J. So I'm just giving all the data step by step. See, just have a look at this. As I already told you, when I fix with 1, when I fix 1, it asks 1 ground, 1 2, 1 3, 1 4. Then when we fix 2, it asks 2 1, 2 2, 2 3, 2 4 like that. This answer. And you can also do modifications in case if there is any